Okay, for today we're going to be looking at section 7.2, finishing that up. So remember your rules. X to the negative 1 is 1 over x. 1 over x to the negative 1 is x over 1. If you have x over y to the negative 1, that's the same as y over x to the positive 1. Anything to the 0 powers 1. Let me think. What else? I think that will probably be enough. So on the first couple, they say evaluate. This goes back to reviewing some things from functions. F of 1. We're going to take f of 1. And remember, we're going to substitute it in for x. So it's going to be 1 to the negative 3 times 1 to the 6th. And 1 to the negative 3 is 1 over 1 to the 3rd. That's just 1. And 1 times 1 to the 6th, that's just 1. Number 10, f of negative 3. We're going to substitute that in for x, so that's going to be 3 times negative 3, but that whole thing gets raised to the negative 4th power. Plus, that's a divided by. You know what I'm going to do with that divided by is I'm just going to put in a fraction symbol. So divided by x squared, so that's going to be negative 3 squared. Okay, so 3 times negative 3 is negative 27. But I think we can do this. 3 times negative 3 is negative 9. So we get negative 9 to the negative 4 over positive 9. So then what I'm going to do is deal with that negative exponent. So I'm going to take and go 1 over negative 9 to the 4th times 9 to the 1st. This 9 to the 1st is already in the denominator. It just stays. And so the final answer is 1 over 9 to the 5th. And that's equal to 1 over 5,904. Okay? Number 11, f of negative 2. So f of negative 2, that's going to equal 2 over negative 2 plus 4 over 3, all of that to the negative 3. Now you could probably use your calculator, but I'm not going to. I'm going to convert the 2 over negative 2 to 3. I'm going to make it negative 3 over 3. That's the same as 2 over negative 2 because I'm going to get a common denominator. So I have that equaling 1/3 to the negative 3. So I'm going to use that rule which says if it's a fraction, you flip the fraction and it becomes positive. So that turns into 3 over 1 to the positive 3. Which then is just 3 to the 3rd, which is 27. Number 12, I'm finding f of 3/4. So that's 3/4 to the negative 6 divided by 3/4 squared. Okay, so for this one, I believe that I brought the 3/4 down to the denominator and have a 1 up on the top. So I made it 3/4 to the positive 6 times 3/4 to the 2nd. Which if we use the rules from previous page, if they have the same base, you can add the exponents. So that's really the same as 1 over 3/4 to the 6 plus 2, or 1 over 3/4 to the 8 Now, 1 divided by 3/4 to the 8 is also equivalent to 1 divided by 3 to the 8th, 4 to the 8th. And that is equal to 1 divided by 3 to the 8 over 4 to the 8, which is really equivalent to 1 over 1 times 4 to the 8 over 3 to the 8, just using some rules of fractions. And what that then gives me really is 4 to the 8th over 3 to the 8th, which is 65536, or 65,536 divided by 6,561. So whenever you have 1 divided by a fraction, notice that really result just turned out to be that fraction flipped. 1 divided by a fraction is always the fraction flipped. Now first I had to apply the 8 exponent to both the 3 and the 4. So here's another example. Okay, 1 divided by a fraction is that fraction flipped. That will come in handy if we can remember that. All right. Take this answer, by the way, and do not put it as a decimal. If you put it as a decimal, it looks irrational, and it is not an irrational number. All right, number 13, I have to write small here. We get f of 1/2 equals 1/2 to the 6th times 1/2 to the -1 plus 1 over 1/2 squared. Okay, so remember we said if we have 1 divided by a fraction, it's that fraction flipped. So we're gonna do that. I think I'll go down here. So 1/2 to the 6th is the same as 1 to the 6th, 2 to the 6th. So that's 1 to the 6th, 2 to the 6th times. Now I got to clean this up in here. Now 1/2 to the -1 is the same as 2 over 1 to the +1. Flip that and it makes the fraction positive. And then this is going to be 1 divided by 1/4, which is going to be that fraction flipped. So it's going to turn out to be 4 over 1. So what we end up with then is 1 over 2 to the 6th, by the way, 64, times 2 plus 4, or 6. So we end up with 1 over 64 times 6 over 1. And that just simplifies. We can do a little cross-simplifying, divide each of them by 2. You get 3 and 32. Final answer is 3 over 32. Okay. So further questions on that, make sure you ask your teacher. Again, I just in this 1 over 1/2 squared, I just did 1/4, and then 1 divided by 1/4 is the fraction flipped. So it becomes 4 over 1 instead of 1/4. All right, write each expression with positive exponents. So 2x to the -2, the -2 is only applied to the x, so this would be 2 over x squared. Versus number 16 is 1 over 2x squared, which becomes 1 over 4x squared. So hopefully you can see the difference. 15, I'm going to make 1 over x squared y to the -3z to the first. That gets rid of that -1 outside. And then I can just simplify the y to the -3 by bringing it up. So it's 1y to the 3rd over x squared z, which is really just y to the 3rd over x squared z. On number 17, if it doesn't have a negative exponent, leave it alone. So x to the 5th stays. I think that's it. But bring up the x to the 3rd. bring down the y to the fourth, and bring up the y to the negative 3 as y to the third. So basically, we took this one and moved this one up, this one and moved up, but took the y to the negative fourth and moved that one down. And then you've got to simplify that. So you've got to use your adding, x to the eighth, and your subtracting gives me negative 1, so that puts the y down in the bottom. So x to the eighth over y. Number 18, negative 2x to the negative 2 would be 1 over negative 2x to the positive 2. And then that turns into 1 over 4x squared, because negative 2 times negative 2 is a positive 4. Number 19, you cannot just bring these, like flip them up and down on, you can't just say it's one fraction, so you have to do 1 over x squared plus 1 over x to the third. And then I got a common denominator and made this one x over x, so that they all say this one would be x plus 1 over x to the third, because that's how you add fractions. Number 20, I'm going to leave the 7 alone and bring the x to the negative 3 up. So it's like this. That just becomes 7x cubed. That's what you do with the negative exponents, okay? Number 21. All right, so I think what I'll do is make the negative exponent on the outside positive. So I think we'll go over here, and on the inside though, well, I can simplify some stuff I see right here. I can, well, I'll just leave it and I'll flip it later, so I'll cancel it later. So I'm going to do negative 8 x to the negative 5 y over negative 64 x to the negative 2 y, all to the third power. So if I literally flip the fraction, it makes the outside exponent positive. Now I see some stuff that can cancel. So I'm going to cancel the 8, the negative, the 64, and that's going to become an 8. Then I'm going to do some moving around here with those negative exponents. So I'm going to take that x to the negative 5 and bring it down to the bottom. It becomes positive. I'm going to take that x to the negative 2 and then bring it up to the top as positive 2. And then I believe that the y's look like they can cancel inside here as well. And remember, this is all to the third power. I've got too much. And then I can do some more simplifying. X squared and x to the fifth cancel to x to the third and 1. So I really just have 1 to the third over x to the 3 times 3, which is just 1 over x to the ninth. I forgot my 8. So, got to go back. Hold on a second. And got to put the 8 in there. And so then we really have 8 to the third in there. So we have 8 to the third times x to the 3 times 3. And then that gives me 1 over 5/12 x to the ninth. So this is all over 1 over 5/12 x to the ninth. All right, and then the last one, number 22, 3a to the negative 1, I'm going to make that positive. So I'm going to bring that down to the bottom. The 3 on the bottom is already positive. It stays. The a to the negative 2 goes up and becomes positive. Then I have a squared over 3a to the first is just 3a times 3. I believe I can cancel an a squared with an a to make it a. My final answer is a over 9. That looks like 9 over 9, but it's a over 9. Okay, that concludes 7-2.